Wireless LAN accessories. Now, so far we've learned about equipment for wireless LAN such as access points, repeaters, bridges, and the antennas for these devices. However, there are also accessories that complement these devices, which is exactly what we're going to learn about in this video. So as you can see here from this bullet list, there's quite a few accessories that we can use in conjunction with our wireless LAN devices. So for example, in our previous video, we learned about antennas that can be used with wireless LAN devices. Well, those antennas need to have cables and connectors that will connect the antenna to the actual wireless LAN device, such as the wireless access points. We'll learn about those type of accessories and others in this video. We're going to kick things off by learning about a device called Power over Ethernet. And to learn about this type of device, we're going to bring up another whiteboard here. Power over Ethernet, or PoE devices, are used to provide power to wireless LAN devices. So let's say, for example, you've done your due diligence and you've done your research on both the wireless access point and the antenna and figured out the best combination for your needs for the optimal wireless coverage for your environment. And then you figured out the best location for this wireless access point and the antenna, and you go ahead and mount it up there, and then you look around and you go, oops, there is no juice. There is no power outlet. How are you going to provide power to the wireless access point? It's one of those Homer Simpson moments where you go, oops. Well, not to fear, you're not going to lose your job for placing the wireless access point in a location where there's no power. What we're going to do is inject a little juice into the stream here. We're going to use a Power over Ethernet device, which is going to inject DC voltage into the Cat5 cabling. So in scenario number 1 here, what we have is a switch and the Cat5 cable going from the switch to this Power over Ethernet device. And this Power over Ethernet device has 2 interfaces. So the switch is going to one interface, and this DC voltage injector will typically be located in the back closet where the switch is located, where there's actually a power receptacle. So this will be plugged into the power. And in turn, you have a Cat5 cable plugged into one interface. And then in the second interface, you have a Cat5 cable going from the DC voltage injector to the wireless access point. So the Cat5 cable will actually be carrying 2 things. It's going to be carrying the data and voltage to the wireless access point. So the wireless access point will have power. Now, one thing to take note of, in order to provide power through the Cat5 cabling to your wireless LAN device, such as the wireless access point, you have to ensure that the device is compliant. You have to make sure that it's 802.3AF compliant. So that is the standard for Power over Ethernet. And so most enterprise-grade wireless access point and enterprise-grade wireless LAN devices will be 802.3AF compliant to allow it to receive power from Power over Ethernet devices. But do make sure, check out the fine print before you purchase those devices to make sure that they are indeed compliant with 802.3AF specification. Now, another thing to take note of is that Ethernet cables can only carry data reliably for 100 meters. So that means that you're limited to a maximum distance of 100 meters for using a Power over Ethernet device to also carry power to the wireless LAN device. So that is a limitation. But if your wireless LAN device is within that 100 meters of the DC voltage injector, that's going to save you a lot of money over installing AC power receptacles close to the wireless LAN devices. So this is a much less expensive solution for getting power to these devices than installing the power where those devices are located. However, let's say that you've got a lot of wireless LAN devices that are going to receive power from a DC voltage injector. Well, that can get pretty crowded in your network closet pretty quickly if you have a lot of these devices and they need power as well. So a solution to a situation where your enterprise has a lot of wireless LAN devices and they're all going to receive power from a DC voltage injector is, instead of using multiple DC voltage injectors, simply to use a switch that will act as a switch and as a DC voltage injector. And this is referred to as an active Ethernet switch. So an active Ethernet switch incorporates a DC voltage injector in addition to being a switch. So it's going to inject DC voltage into the ports that you connect your Cat5 cabling into. Now, oftentimes most active Ethernet switches have some intelligence. They auto-sense whether or not you've connected a Power over Ethernet client device into the switch. So, for example, it will provide DC voltage power to our wireless access point that is a PoE client or a PoE device. However, if you connect another device that is not a PoE device, it will not provide power to that device. So it's auto-sensing. I'll give you power if you require that power and you are an 802.3AF device. If you're not, I'm not going to give you power. So now you might be asking yourself, well, what if my wireless access point is not a PoE compatible device? What do I do there? Well, that's an excellent question, and I'm glad you asked that. Let's bring up another whiteboard and address that. So in the diagram here, it's very similar to the diagram in our previous whiteboard. In this situation, we've got a switch, which its Cat5 cabling is going into the DC voltage injector, and the outgoing Cat5 cabling in this example is going into a device which is called either a picker or a tap. So what this picker is going to do is going to pick off the voltage that has been injected into the Cat5 cabling, and then it's going to have a splitting functionality, if you will. It's going to split off the data portion that's run along the Cat5 cabling and the DC voltage that is running along the Cat5 cabling. So on this side, we've got two interfaces, one for Cat5 and one for plugging in a DC voltage adapter, which in turn is going to plug into our non-PoE compatible device. So the picker is essentially acting as a middleman between the DC voltage injector and the wireless access point. So it's, again, picking off the voltage, separating the voltage from the data, and then on this side it's then passing the voltage and the data along to the wireless access point using the appropriate interfaces, so a DC voltage plug and a Cat5 cabling. Now, something to take note of when you're purchasing Power over Ethernet devices is that the standard for these devices, which again is 802.3AF, really only became a standard relatively recently. It wasn't until late of 2003 that this became a standard. And as a result, there's still a lot of proprietary equipment out there that uses different voltage and different pinouts for supplying the voltage on a Cat5 cabling. So you want to make sure that the vendor that you purchase your Power over Ethernet devices uses the standards, or ideally you want to use the same vendor for all of your Power over Ethernet devices, so you ensure that you get the same voltage and the same pinouts that are used for delivering the voltage over the Cat5 cabling. Also, there are different types of injectors and pickers. Let's bring up another whiteboard and learn about these types. Now, first off, there are two types of injectors that you can purchase, either a fault-protected or a passive injector. The passive injector simply injects all the DC voltage right into the line without providing any fault protection whatsoever. So you're not going to be able to provide any short circuit or overcurrent protection when you use a passive injector. So the standard, the 802.3AF standard, stipulates that the maximum of 48 volts of direct current can be used for Power over Ethernet devices. So a passive injector would inject 48 volts of direct current right onto the Cat5 cabling without providing any type of fault protection monitoring. In contrast, it's pretty straightforward here. If you purchase an injector that does provide fault protected monitoring, then you're going to get monitoring for short circuit and overcurrent conditions. And similarly, there are two different types of pickers that you can purchase. You can purchase either a regulated or a passive picker. A passive picker simply takes all that injected voltage. So it takes it's taking the voltage that has been injected into the Cat5 cabling. It's going to take all that voltage, the 48 volts of direct current, and direct that to the device that you have, whether it's an access point or a bridge or what have you. In contrast, a regulated picker is going to take the 48 volts of direct current and it's going to convert that voltage into another voltage. Say, for example, it's going to take the 48 VDC, the voltage direct current, and it might convert that to, say, for example, 12 VDC or even 24 VDC, or something that's compatible with your wireless LAN device. Now, in addition to installing injectors and pickers in line with a wireless LAN device, there are other devices that we can install in line with a wireless LAN device, such as an RF amplifier or an RF attenuator. Let's first take a look at an RF amplifier by bringing up another whiteboard. Now, in a nutshell, an RF amplifier is essentially used to amplify or boost weak RF signals being sent or received by antennas. And this weakness may be caused by the distance between the sending and receiving antennas, or by the length of the cable from the wireless LAN device, such as a wireless access point or a bridge or repeater, to its associated antenna. Now, there are two types of RF amplifiers that can be used to boost the RF signal. First one is unidirectional, and the second one is bidirectional. Unidirectional is used to help compensate for signal loss that is incurred when you're using long RF cables between the wireless LAN device, such as an access point, and the antenna. So the unidirectional RF amplifier will increase the signal level before it's actually injected into the transmitting antenna. So this type of RF amplifier will intercept the RF signal that is sent from, say, for example, the wireless access point's radio. It's going to take that signal, amplify the signal so it can get it across that long cabling and then out through the antenna that the cable is connected to. Now, in contrast, a bidirectional RF amplifier is used with the receiving antenna. So it's used to boost the sensitivity of the receiving antenna by amplifying the received signal before it actually reaches the wireless LAN device, such as our wireless access point. Now, of these two types of RF amplifiers, a bidirectional RF amplifier is the one that is most commonly used within an enterprise wireless LAN. Now, let's bring up another whiteboard to take a look at the typical installation of either a unidirectional or bidirectional RF amplifier. So let's bring that up right now. So in this illustration, we actually have four components. We have a wireless access point, its antenna, we have an amplifier, and we also have a DC voltage injector. The RF amplifiers are typically power over Ethernet devices, so they receive their power from a DC voltage injector. So in this example, we have an amplifier that is receiving the signal from the radio. It's receiving power from the DC voltage injector, and this is all installed in series, so it's receiving and intercepting the RF signal, boosting the RF signal, sending that along to the antenna, and bada bing, bada boom, we have amplified that signal. Now, and the reverse would be true with the bidirectional. It would boost the sensitivity of the antenna, and as a result help to clean up any signal loss, any noise on the line by amplifying the RF signal and then passing that along the cabling to the actual wireless access point. So if you're installing a unidirectional RF amplifier, you want to have that as close as possible to the wireless LAN device. And if you're installing a bidirectional RF amplifier, you want to have that as close as possible to the receiving antenna. So there's a very short distance between the cable length of the bidirectional RF amplifier and the receiving antenna. So to ensure you've got a nice, strong, clean, amplified signal. Now, in addition to the different types of RF amplifiers, a couple of other things to take into consideration are very similar to the purchasing of other wireless LAN devices. We want to look at the specs of our RF amplifier. What's the impedance level? What's the gain level? What's the VSWR level? What's the output level? Also, very important to check is the frequency range or the frequency response of our RF amplifier. So let's say, for example, your wireless LAN uses wireless LAN devices that operate in the 5 gigahertz spectrum. However, you go out and purchase an RF amplifier that only works at the 2.4 gigahertz frequency spectrum. Well, that's not going to work for you. You're going to need an RF amplifier in this particular example that's going to operate all the way up to the 5 gigahertz frequency spectrum. So make sure that the frequency range of the amplifier that you're purchasing matches the frequency range of your existing wireless LAN devices. Now, as I mentioned before, in addition to RF amplifiers, we can also use an RF attenuator within our wireless LAN. And let's bring up another whiteboard and learn about those. So in contrast to an RF amplifier, which again is used to amplify the RF signal, an RF attenuator is used to decrease the RF signal. So you're probably asking yourself now, why in the world would I want to decrease the RF signal? We just learned about the benefits of amplifying the signal. Why am I decreasing it? Well, if you need to rein in the maximum power output to stay within FCC rules, then an attenuator is a best bet for staying within that power output rules, maximum power output rules, by decreasing the RF signal in very precise measured ways. So for example, let's say that you have a wireless access point that has a fixed output power of 100 milliwatts, but then you get a very, very high gain antenna and you connect that to that wireless access point, which in turn quadruples your output. So it quadruples the EIRP of that wireless LAN device, and as a result of that, you exceed the FCC rules for the maximum power output for that device. Well, by placing a RF attenuator in series with your wireless access point and the antenna, you can decrease the RF signal strength and as a result decrease the maximum power output and stay within FCC rules. Now, similar to RF amplifiers, there are two different types of RF attenuators. The first type is a fixed loss attenuator, and as the name conveys, this allows us to get an attenuator which will decrease the RF signal by a fixed amount. And then the second type of RF attenuator that you can purchase is a variable loss attenuator. And as this name conveys, it allows an administrator to configure the exact amount of loss that you would like in the radio frequency signal. However, variable loss attenuators are typically not used in wireless LAN systems because they could inadvertently get changed, meaning the settings, the loss amount can inadvertently get changed, and as a result you can fall out of compliance with the FCC rules or simply just damage your equipment. It could damage the antenna, damage the wireless access point or the bridge or the repeater. So for wireless LANs, fixed loss attenuators are the ones that are used. And now let's bring up another whiteboard and take a look at a typical installation of an RF attenuator. So in this example we have a wireless access point, which in turn is connected in series with the RF attenuator, which is right here, which is in turn connected to the antenna. So before the signal reaches the antenna, the attenuator is in the middle and it's going to degrade that signal by a fixed amount. And again, the same rules hold true here for purchasing RF attenuators as they do for RF amplifiers. You want to look at their specifications, look at their impedance ratings, look whether or not it's fixed or variable loss, look at the input power, the amount of fixed loss, the frequency range, etc. So make sure you've got all your ducks in a row, really is what it amounts to, prior to purchasing your wireless LAN equipment. Now, the basic functionality of a lightning arrestor is simply to take the surge of electrical current that's generated by an indirect lightning strike and redirect, or what's also referred to as short, that electrical current into the ground. And let's bring up another whiteboard and take a closer look at how a lightning arrestor can help to arrest these surges of electrical energy from burning out the devices in our wireless LAN. Now, the very first thing you need to know is that a lightning arrestor is not capable of withstanding a direct lightning strike. So if lightning were to strike the antenna, you can pretty much kiss that antenna goodbye, and that's a technical term. That means that antenna is fried. It is toast, and it's no longer going to work, and that lightning arrestor isn't going to help you one little bit there. What the lightning arrestor is useful for, and what it's made for, is to deal with lightning strikes that occurred to nearby objects. So let me explain that. right here we've got a tree and we've got the Yagi antenna for our wireless LAN. Let's say, for example, some lightning hits the tree. The tree takes the direct strike from the lightning. As a result, the tree bursts into flames and it's not having a good day. However, what is also going to happen is that after the lightning strikes the object, such as our tree right here, high amounts of electrical current will flow from the tree to hit nearby objects, or flow to nearby objects, such as the Yagi antenna for our wireless LAN. So this surge of electrical current is going to go to the antenna, and what's going to happen at that point is that the lightning arrestor is going to sense this surge of a current, and it's going to immediately redirect or short that excessive current right into the ground. Now, I said immediately, but a lightning arrestor can't do it at that very moment, at that very second. It comes very, very close to it, but there's actually an IEEE standard which governs how quickly or how much time should elapse before a lightning arrestor does redirect the electrical current to the ground. And the IEEE standard, if you want to have a lightning arrestor that is compliant with the IEEE standard, the lightning arrestor should be able to redirect that electrical current in less than 8 microseconds. So it's very, very fast, and in all intents and purposes, it's almost immediately, but it has to happen within under 8 microseconds. And a couple other things to bear in mind about lightning arrestors in general is that most of them will have this little glass tube inside the lightning arrestor, which will break when the voltage of the lightning arrestor begins redirecting that surge of current. So that's a visual cue to you. It's a visual indicator that electrical current, such as the current from a lightning strike, has caused a surge, and the lightning arrestor redirected or shorted that surge to the ground. And this glass tube can be replaced. And along the same lines, it's more cost effective in the long run to get a lightning arrestor that is reusable. Now, some lightning arrestors are not reusable. It's a one-shot deal, so to speak. You get that shot of lightning and poof, that thing's gone. It has to be replaced. However, you can buy reusable lightning arrestors, and they are certainly more cost effective in the long run. And how often they can be reused depends on manufacturer to manufacturer, lightning arrestor to lightning arrestor. A couple of other things you want to watch out for is, can the lightning arrestor actually pass DC current through? Let's say, for example, you have a RF amplifier. And again, the RF amplifier is typically going to receive its DC current from a power over Ethernet configuration. So if you have this installed in series before the amplifier, you want the lightning arrestor to be able to pass the DC current through the lightning arrestor to the RF amplifier. However, it's best practice to place the lightning arrestor as the very, very last component on the line, so to speak. You want to have this just before the antenna, and you want to place your RF attenuators or RF amplifiers and power over Ethernet devices and all that kind of stuff behind the lightning arrestor. So by doing that, you'll hopefully be able to protect your RF amplifier and attenuator, etc., your bridge, your access point, whatever the case may be, from these surges in electricity. So you want to place this right here as the very last part in your chain before the antenna. However, one thing you have to watch out for is that when you introduce a new component in the transmission path for the RF signal, you're going to insert what's referred to as insertion loss. The radio frequency signal now has something else to go through before it goes to the antenna or comes through from the antenna. So when you're looking at the specifications for a lightning arrestor, you want to ensure that the insertion loss that is incurred by inserting a lightning arrestor is very, very low, about 0.1 decibels. So you want to have this at an extremely low insertion loss. And you also want to look at the other specifications for a lightning arrestor, such as its impedance and its frequency response range, just as we look at for all of our other accessories that we use within a wireless LAN. So that's how a lightning arrestor functions within a wireless LAN environment. Let's take a look at another accessory called a RF splitter and see what we can use that for in our wireless LAN. Now, as the name conveys, an RF splitter is used to split the single RF signal that's coming from the radio into multiple independent RF signals. So we can split this into 2 different signals, or 3 different signals, or 4 different signals. And an RF splitter isn't found within a wireless LAN that often. It's primarily used for connecting more than one antenna to a single radio. So we've got a single access point, for example, and we'd like to have multiple antennas. Let's bring up another whiteboard and see how this might be installed. So in this example, we have a wireless access point, which in turn is connected to the splitter, which in turn splits the RF signal into 2 separate independent channels, if you will. So the primary benefit for this type of configuration, where we have multiple antennas being connected to our access point through a splitter, is that we can have a broader coverage area. So for example, in this illustration here, we have a Yagi antenna pointed in this direction, and then another Yagi pointed in the opposite direction. So in this example, because our Yagi antennas are directional antennas and they have a narrow beam width, this type of configuration would be excellent for along a roadway or a long path. So we have this bidirectional coverage with these 2 antennas sort of going forward and going backward. Now, a couple things to bear in mind when you're using this type of configuration is that you want to have the input for the RF splitter facing the actual RF signal. So for example, we want to have the input for the signal facing our wireless access point. And we also want to ensure that the cable lengths that are going from the outputs of the splitter to the different antennas here are of equal length, so we don't introduce more loss, because number one, we're splitting the single RF signal now into 2 different independent signals, and the longer the length of the cable, the more attenuation that we have. So we want to ensure that the length of the cable that is being split off in these 2 independent RF channels is of equal length. So we reduce the amount of attenuation by adding in these new cables. And again, each time we introduce a new component in the cabling between the wireless access point or the wireless LAN device and the antenna, we're inserting loss. So we also want to ensure that when we look at the specifications for the RF splitters, that the insertion loss of the splitter is very low. Typically, you want to have an insertion loss of less than 0.5 decibels, if at all possible. So again, just by introducing this one little component, that's slowing down the RF signal. We're reducing the amplitude of the RF signal, so we want to ensure that we have devices or components that have low insertion loss. And again, you also want to ensure that the specifications for the frequency range, the impedance rating, the VSWR rating are all within compatibility with the devices that you're using for your wireless LAN. And speaking of specifications, you also need to ensure that the connectors that are used, so for example, right here we've got a little connector that's used to connect the cable to the wireless LAN accessory. You need to ensure that the connectors that are used for your wireless LAN accessories comply with FCC rules. Let's bring up another whiteboard and take a closer look at connectors that are used within a wireless LAN environment. So here we see 3 different types of connectors that are typically used for connecting wireless LAN accessories. And the first type of connector is an N connector, then we have an RP-TNC connector, and then at the very bottom we have an RP-SMA connector. Now the N connectors all these connectors are gender-based. We have a male connector which is inserted into a female connector. The N connectors are referred to as standard type connectors and are meant to be installed by RF professionals, professional administrators that work with radio frequency products. Now by standard I mean non-proprietary. So that means that if you were to purchase standard N-type connectors from company A, they will work with the standard N-type connectors that are manufactured from company B. However, when you see connectors with the prefix of RP, which stands for reverse polarity, that means that these are proprietary connectors from that manufacturer. And reverse polarity simply means that the contacts have been reversed within a standard body. So we could have a standard N body or a standard TNC body or a standard SMA body, for example, and reverse the contacts, meaning that the male and female are reversed, where the male connector is the same design except that the center conductor is actually the socket. So they've been reversed the polarity within the standard connector. And the reason why there are standard and non-standard or proprietary connectors is due to the fact that in 1994 the FCC basically handed down this edict. This edict is a rule called Part 15, and when you go and purchase connectors, you often see a little sentence saying the connectors meet FCC Part 15 rules and regulations. And the basic gist of the rules and regulations of Part 15 is that products that are used in the 2.4 and 5 gigahertz spectrum must use connectors that are either unique and non-standard, meaning that they're proprietary, or that they be designed to be professionally installed by an RF professional. And one of the main reasons why the FCC created this rule was to prevent stock antennas that are part of an FCC certified system from being replaced with a high gain antenna that has not been certified by the FCC. And at the end of this video we'll learn about what an FCC certified system is. But this rule is also put into place to help prevent home-brewed systems from being created, from people from creating their own type of antenna out of coffee cans and metal and stuff that they have in their backyard and their workshop. The FCC wants to ensure that the antennas and RF devices have been certified, and by creating these proprietary connectors, that helps to ensure that you can't mix and match between devices and accessories. So for example, if you were to have an accessory such as an amplifier that has a connector with a standard TNC connector that you try to connect to an antenna that has an RP or a reverse polarity connector, you wouldn't be able to connect those two together. You wouldn't be able to what's referred to as mate those two connectors together. And if you think about it, there's a lot of wireless equipment that's being installed now in the home environment and a small office, home office environment by non-professionals. So you'll find with these type of equipments, they'll use RP connectors in an effort to help prevent home users or non-professional users from mixing and matching different equipment, and as a result create a non-certified, a non-FCC certified system. And that's why a lot of companies that are setting up wireless LAN will purchase their antennas, their cablings, their connectors, their wireless LAN infrastructure devices from a single vendor, so everything fits together and complies with the FCC rules. So these are, again, typical type of connectors, but again, I hesitate to say standard type of connectors. When you see a connector that does not have RP in the front of it, that is an industry standard connector. When you see a connector that does have RP in front of it, again, that is a non-standard or proprietary connector. And similar to purchasing the other wireless LAN accessories that we talked about, there's a specification checklist that you should go through when you're purchasing connectors for your wireless LAN. And let's bring up a whiteboard and take a look at that checklist. So first off, you want to ensure that the impedance of the connectors matches the impedance of the cabling and the other accessories that you have installed within your wireless LAN system that you're putting together. You also want to know how much insertion loss is caused by a connector, and you also want to know the frequency range of the connectors. So for example, is the frequency range 0 to 3 gigahertz? Well, if you're using a 5 gigahertz wireless LAN infrastructure devices, that frequency range is not high enough. You would need to get a frequency range of 0 to 5 gigahertz instead of 3 gigahertz. Make sure you've got the right type of connectors and the right gender. Make sure you've got a male and female, and make sure that you have the, as we just discussed, either the proprietary connectors that will work with the connectors for your antenna or other accessories. So spend some time, make sure that you've got the right type and the right gender of connectors. And these connectors aren't that expensive, but do spend a little more to get good quality connectors. Again, this is a focal point of where you're connecting your antenna to other accessories. So you don't want to scrimp and try to save a few pennies with this connection, because you don't want to have RF signal loss at this point. And make sure you get the good stuff. Splurge, have fun. Now, if you remember earlier, I'd mentioned that RP, or proprietary type connectors, were created in response to the FCC ruling Part 15 to require that the connectors either be proprietary or they be installed by a professional. Well, there's a cable that lets you get around that a little bit. Let's bring up another whiteboard and take a look at what's referred to as a pigtail adapter cable. Now, in a nutshell, a pigtail cable is used to adapt two different kinds of connectors. So, for example, we might have one connector on the pigtail cable that's a standard connector, and the other one is a proprietary connector. So, for example, you might have a wireless access point with a proprietary connector, but you've purchased this antenna that has a cable with a connector that is a standard connector. So, with a pigtail adapter cable, we can plug in the appropriate pigtail cable with the appropriate proprietary connector into the wireless access point, and at the other end, where we have the standard connector, we can use that to connect into the antenna that we had purchased. So in a nutshell, there are standard RF cables. They have the same type of connector at either end. Then we have adapter cables, which are referred to generically as pigtail cables, which have different connectors at either end. Now let's bring up a whiteboard and take a look at a picture of these two types of cables. So at the top here we see a standard RF cable which has the same connectors at either end. This is an LMR 400 series cable, which is a fairly standard cable. It's kind of a middle of the range cable where it's got good low loss cable. It's not the best cable, it's not the worst cable, it's kind of like right in the middle. And just a little note to you though that the cables that have the best low loss rating, meaning the cable that has the lowest low loss ratings, are going to be very, very expensive. They're usually about $5 to $6 to sometimes $10 per foot for an extremely ultra low loss cable. And then at the very bottom we have the pigtail cable, which again is used to adapt typically a proprietary connector to a standard connector. So on the right hand side we have a proprietary connector for a wireless BCM-CI card, and then on the right hand side we have a standard connector. And that completes our look at RF cables. Now our next accessory is really helpful when we have a lot of companies in the same broadcast vicinity that are using the same spectrum. We can use a frequency converter, let's say for example where we have a multi-tenant building, and in that multi-tenant building there are say 6 floors. And everybody has their own wireless LAN on each of these floors. They're different companies. And maybe there's a company on floor 3 that wants to establish a wireless LAN bridge to an office space that they have across the street. Well, remember, in the 2.4 gigahertz band, there are only 3 channels that are non-overlapping channels. And if we have a lot of companies in the same broadcast vicinity that all have their own LAN set up, and if we want to connect 2 different wireless networks together that are on different channels via a bridge, we can run into some problems here. We can run into some interference with other wireless LANs on the same system hosted by other companies. So the solution to that problem is to use a frequency converter to upconvert the 2.4 gigahertz radio signal to the 5 gigahertz spectrum. So we can use this frequency converter that we have here down below in the picture, which can operate all the way up to the 5.8 gigahertz spectrum. And this is completely transparent to the user. The radio, the actual wireless access point or the wireless bridge or the wireless repeater, operates at the 2.4 gigahertz spectrum. The wireless network adapters will operate at the 2.4 gigahertz spectrum. The only 2 components that you'll need are an antenna that operates at the 5 gigahertz spectrum, an converter that operates in the 5 gigahertz spectrum, and wires that go between the converter to the antenna that also function in the 5 gigahertz spectrum. So again, this is all very transparent to the users. They don't know that any of this smoke and mirrors is happening in the background. So again, when the 2.4 gigahertz radio signal is sent, the converter is going to upconvert that to the 5.8 gigahertz band, and then when it receives the 5.8 gigahertz signal, it will downconvert that to the 2.4 gigahertz band. So a frequency converter is a real cool method, very economical method for you to be able to give yourself a little bit of elbow room, if you will, in the crowded 2.4 gigahertz band, and to have this uptick and to allow you to get out of that crowded band into a more available band with less channel overlapping in the 5.8 gigahertz band. And now, last but not least, is a very important point that covers everything that we've talked about, and that is all these accessories that we can connect with our wireless LAN devices must be part of a system that has been certified by the FCC. Let's bring up another whiteboard and learn more about this. Now, the FCC defines a wireless LAN system as the transmitting device. So, for example, your wireless LAN infrastructure device, the access point, the bridge, the repeater, and any accessories that are used with that infrastructure device, such as the cables, connectors, amplifiers, attenuators, splitters, and lastly, the antenna. Now, the FCC has mandated that wireless LAN systems have to be certified, and that means that the complete system, whether you just have an access point or an access point with all these accessories, has to be certified as a complete system and given a certification number by the FCC. And the certification will have a list of all the components that comprise the complete certified system. Now, you might be thinking to yourself, well, wait a second. When I purchased a wireless access point, I didn't have to go to the FCC and get this certification. Well, what happens is that the manufacturers of this wireless LAN equipment will obtain an FCC certification for their hardware, such as your wireless access point. So they get a certification from the FCC stating that this wireless access point, including its radio and antenna, are a complete certified system. Now, the big gotcha that you have to watch out for is if you were to purchase additional devices, additional accessories for your certified system, such as your wireless access point, and then connect those accessories to your system, such as an antenna or an amplifier, well, that means that the manufacturer's certification for that wireless access point is null and void. That no longer applies because you've created a new system. You now have a wireless access point and an antenna or an amplifier. So remember, all of the devices that you have strung together, connected together, are a system. And all of those devices have to be certified by the FCC. And to take things one step further, the FCC doesn't allow an amplifier to be sold if it's not part of a certified system. So in this situation, in order for manufacturers of amplifiers to actually be able to sell their amplifiers, what they'll do is that they'll obtain an FCC certification for an entire system by including their amplifier with another vendor's wireless LAN hardware together. So another example of this would be if you were to purchase an antenna from one manufacturer and a wireless access point from a different manufacturer, and they have their own separate FCC certifications for those systems, and then you combine the two together, you add the antenna to the wireless access point, well, in all likelihood, those two components probably have not been certified as a system together by the FCC. So the moral of the story is, when you go to purchase these accessories, you want to ask the vendor for a copy of the FCC certification as a system. So you want to see that if I buy this antenna, what other hardware devices can I use this with and it still be considered part of an FCC certified system. And to top it all off, the FCC rules that govern this stipulate that the person who installs the wireless LAN equipment is responsible to ensure that they're installing an authorized certified system. So watch out there. And on that note, that brings us to the end of this video. Let's bring up our whiteboard and do a recap of what we've learned. So in this video, we start off by learning that if our wireless devices, such as an access point, is not located near a power outlet, we can still provide power to it via the Cat5 cabling that is connected to, in conjunction with either an active Ethernet switch or what else? That's right, a DC injector. And we can also inject a little amplification for RF signals by using an amplifier. And again, that's going to increase the signal strength. In contrast, if we use an attenuator, it's going to decrease the RF signal strength. And I know that this is shocking news, but our wireless equipment that is set up outdoors, especially our antennas and the coaxial cables that run to the antennas, are susceptible to surges, electrical surges that have been generated from lightning strikes. Remember, the lightning arrestor is not designed to protect against a direct hit. It's designed to protect against electrical surges that come from lightning strikes that hit a nearby object, such as a tree or something like that. So ensure that you have lightning arrestors to help protect your wireless equipment that is located outside. Also, we can add additional antennas to our wireless access point or bridge or repeater by using an RF splitter. But in order to connect our RF cables and splitters and attenuators and amplifiers and everything together, we need connectors. So remember, though, that there are two types of connectors. We have standard connectors, and then we have non-standard or proprietary connectors, and those connectors have the prefix of RP for reverse polarity. And remember that we have got two general types of cables. We have our RF cabling, and then we have the pigtail adapter cabling, which allows us to have two different types of connectors, so we can adapt to a standard, to a non-standard, or proprietary devices. And then we finished off by learning that we can convert the frequency range of our wireless LAN to another frequency. So, for example, if our wireless LAN is running at the frequency of 2.4 gigahertz, we can use a 5.8 gigahertz antenna in conjunction with a frequency converter that will convert the frequency either up or down from 2.4 gigahertz to 5.8 gigahertz and vice versa. And again, frequency converters are primarily used to decongest the crowded 2.4 gigahertz spectrum. And with that, that brings us to the end. I hope that this video has been informative for you, and I'd like to thank you for viewing.